This was the Big Bang, the beginning of the universe. But was there anything before the Big Bang? If not, what created the universe? Why did the universe emerge from the Big Bang the way it did?
How did the universe come to be? The idea that the universe began with a Big Bang is firmly entrenched in the minds of billions of people for years. But the so-called science isn't nearly as settled as most people are led to believe. Many scientists know there are big problems with the idea, and the new images from the James Webb Space Telescope just deepen concern. NASA's $10 billion time machine has discovered 6 gigantic galaxies that emerged shortly after the cosmic dawn, stunning scientists by forming at a speed that upends the current understanding of the early universe. Even the renowned physicist Michio Kaku has even broken his silence to discuss the James Webb Telescope's most breakthrough image in history.
These are not baby galaxies at all. They're actually monstrous black holes. Black holes that formed after the instant of creation. That's baffling scientists because they don't fit in the normal sequence of the birth of a galaxy. So I personally think that we're actually looking at monster black holes where perhaps new laws of physics are emerging. And again, if you can figure all this out, there could be a Nobel Prize waiting for you.
Is our understanding of the universe being transformed again? Stay tuned as we reveal the mysteries of these extraordinary galaxies and delve into the awe-inspiring revelations brought to light by the James Webb Telescope. But first and foremost, we need to understand what cosmologists know or think they know about the universe. After the Big Bang, the infant universe began cooling off. Within a few million years, the roiling plasma that filled space settled down, and electrons, protons, and neutrons combined into atoms, mostly neutral hydrogen. Things were quiet and dark for a period of uncertain duration, known as the Cosmic Dark Ages. Something happened. Most of the material that flew apart after the Big Bang is made of something we can't see, called dark matter. It has exerted a powerful influence over the cosmos, especially at first. In the standard picture, cold dark matter, a term that means invisible, slow-moving particles, was flung about the cosmos indiscriminately. In some areas, its distribution was denser, and in these regions, it began collapsing into clumps. Visible matter, meaning atoms, clustered around the clumps of dark matter. As the atoms cooled off as well, they eventually condensed, and the first stars were born. These new sources of radiation recharged the neutral hydrogen that filled the universe during the so-called epoch of reionization. Through gravity, larger and more complex structures grew, building a vast cosmic web of galaxies. Meanwhile, everything kept flying apart. The astronomer Edwin Hubble figured out in the 1920s that the universe is expanding, and in the late 1990s, his namesake, the Hubble Space Telescope, found evidence that the expansion is accelerating. Think of the universe as a loaf of raisin bread. It starts as a mixture of flour, water, yeast, and raisins. When you combine these ingredients, the yeast begins respiring and the loaf begins to rise. The raisins within it stand, inns for galaxies, stretch further apart from one another as the loaf expands. The Hubble telescope saw that the loaf is rising ever faster. The raisins are flying apart at a rate that defies their gravitational attraction. This acceleration appears to be driven by the repulsive energy of space itself, so-called dark energy, which is represented by the Greek letter L, pronounced lambda. Plug values for lambda, cold dark matter, and regular matter, and radiation into the equations of Albert Einstein's general theory of relativity, and you get a model of how the universe evolves. This lambda cold dark matter CDM model matches almost all observations of the cosmos. One way to test this picture is by looking at very distant galaxies, equivalent to looking back in time to the first few 100 million years after the tremendous clap that started it all. The cosmos was simpler then, its evolution easier to compare against predictions. Astronomers first tried to see the earliest structures of the universe using the Hubble telescope in 1995. Over 10 days, Hubble captured 342 exposures of an empty-looking patch of space in the Big Dipper. Astronomers were astonished by the abundance hiding in the inky dark. Hubble could see thousands of galaxies at different distances and stages of development, stretching back to much earlier times than anyone expected. Hubble would go on to find some exceedingly distant galaxies. In 2016, astronomers found its most distant one, called GNZ 11, a faint smudge that they dated to 400 million years after the Big Bang. That was surprisingly early for a galaxy, but it did not cast doubt on the CDM model, in part because the galaxy is tiny, with just 1% of the Milky Way's mass, and in part because it stood alone. But when the James Webb Space Telescope came along, our story of the universe is scrambling once again. NASA's $10 billion gamble, in full operation since last summer, has shown that galaxies formed much sooner after the Big Bang than scientists previously thought, and that some of them are unexpectedly large, absolutely brimming with stars. The findings have thrown scientists into a new reality in which their existing theories no longer apply. Everyone in the astronomy community knew that the Webb telescope was going to be revolutionary, and we had a very clear list of things that we thought Webb would totally blow our socks off about. Joel Leger, an astronomer at Penn State University, said, "But the discovery of the cosmically chunky galaxies where there shouldn't be any. This was nowhere on it. No one was looking for this. Instruments like Hubble and Webb are something like time machines. When the observatories look out into the depths, they're basking in starlight that left its source eons ago and has been traveling across the universe toward us ever since. In other words, to understand the cosmic beginning, astronomers must look for the most distant galaxies. Before Webb, scientists believed that those early distant galaxies emerged at a leisurely pace. The first stars formed when clouds of hydrogen gas collapsed in on themselves and ignited. Then, gravity drew the ancient orbs together into galaxies. All of this, drawing together of disparate matter into massive cosmic neighborhoods, was assumed to have taken at least 1 billion years. Sure, the most distant galaxy that Hubble ever spotted was unexpectedly bright for the cosmic conditions of the time, indicating a larger collection of stars than should have been possible. But astronomers didn't think too much of it then. They expected that Webb, with its ultra-powerful infrared vision, would uncover the starter galaxies that they anticipated and that Hubble couldn't see. "Ah," said the shiny new telescope. In Webb's first weeks, as astronomers raced to find the most distant galaxies ever detected, they wondered whether the data were actually wrong. The ancient galaxies were just too big and bright. A recalibration of Webb's instruments soon showed that some measurements were off, making some galaxies appear more distant than they actually were, and some claims were revised. But the big picture findings stuck. The early universe was somehow bold and brash and remarkably luminous. The objects we're finding are as massive or larger than the Milky Way, which is astounding, said Leher, who published a paper last week that identified 6 enormous galaxies that existed just 500 million to 700 million years after the Big Bang. One of these galaxies may have amassed 100 billion times that of our Sun. Our own galaxy similarly contains many billions of stars, but it has had 13 billion years to reach its size. For a brief moment, this new reality seemed to threaten astronomers' fundamental understanding of the entire cosmos. If the starting point looked like that, Could the standard model of cosmology, our strongest theory about the origins and composition of the universe, the one that didn't account for what Webb found, be wrong? But astronomers now believe that the theory can accommodate the new telescope's surprises. Recent computer simulations guided by the standard model have shown that the universe could indeed have created some of the galaxies that Webb has found. What are your thoughts on this? Let me know in the comments.